Her discoveries have revolutionized our understanding of the microbial world and opened new frontiers in medicine, industry, and environmental science. Dr. Bonnie Bassler's groundbreaking research lies in quorum sensing, a phenomenon that reveals how bacteria communicate using chemical signals. These signals allow bacteria to coordinate complex behaviors, from forming biofilms and regulating virulence to emitting bioluminescence.
As bacteria divide and grow in numbers, they make and release small chemicals that we call autoinducers. So the more cells there are, the more of these molecules there are around them.
Dr. Bassler's work has fundamentally changed how we view bacteria, not as isolated, primitive organisms, but as highly social and sophisticated entities capable of intricate collaboration. Her career is a testament to the power of interdisciplinary exploration. Combining genetics, biochemistry, and structural biology, Dr. Bassler continually pushes the boundaries of knowledge, unraveling the complex behaviors of the microbial world.
This ability of bacteria to communicate and work in groups is vital to their success in the world.
Proving that even the smallest organisms can inspire the biggest ideas.
David Tilman, a distinguished ecologist and Regents Professor at the University of Minnesota's College of Biological Sciences, has worked to redefine how we understand the delicate balance of nature. His journey into ecology began unexpectedly during a biology lecture.
I realized that it had all of the depth and complexity that I loved about physics, all of the chance for mechanism and causation, and the work that you did in it was directly relevant to lots of the environmental problems the world was facing then, and they're much more serious now.
After earning a bachelor's in zoology and a PhD in ecology from the University of Michigan, Dr. Tilman embarked on a career focused on answering one pivotal question: how do human impacts on nature come back to affect us? His groundbreaking research combines mathematics and biology to explore the intricate relationships between plant species and ecosystems. At the Cedar Creek Ecosystem Science Reserve, Dr. Tilman conducted landmark experiments demonstrating how species diversity strengthens ecosystems against climate change, invasive species, and habitat destruction. His findings not only advanced ecological science, but also provided actionable insights into sustainable agriculture and conservation practices. Beyond his research, Dr. Tilman has mentored countless students and scholars, shaping the next generation of ecologists.
Dr. Helen Blau has spent her career challenging scientific dogma and uncovering the hidden potential of cellular plasticity. Dr. Helen Blau's work has revolutionized our understanding of stem cells, reshaping the landscape of aging research and therapeutic innovation. Groundbreaking work in cellular plasticity challenged the belief that differentiated cells are fixed and irreversible. Dr. Blau's research laid the groundwork for modern advances in induced pluripotent stem cells. One of her most notable achievements includes leading one of the first clinical trials of cell therapy for Duchenne muscular dystrophy. Her team's findings revealed the disease's link to telomere and stem cell exhaustion, opening new avenues for treatment. Her discovery that prostaglandin E2 rejuvenates aging muscle stem cells offers hope for combating muscle wasting or sarcopenia. A passionate advocate for science communication, Dr. Blau authored Stem Cells to the Rescue, a poetic and illustrated children's book designed to educate and inspire curiosity in readers of all ages.
Take risks. Don't be afraid to think big, and don't be put off by failures. Failures are part of the process. Be curious, be brave, be bold, and enjoy what you're doing.
Dr. Keivan Stassun doesn't just study the stars. He uncovers the hidden wonders of the universe, one breakthrough at a time. A leading astrophysicist at Vanderbilt University, Stassun's research on star evolution, exoplanets, and binary star systems has reshaped our understanding of cosmic phenomena.
It is hard for me to imagine anything more thrilling as that moment of discovery.
Dr. Stassun's research on binary star systems has enabled precise measurements of stars' size, mass, temperature, and density, enhancing our understanding of stellar evolution. His work has also contributed to the detection and characterization of exoplanets, refining methods for studying distant worlds and their potential for habitability. By combining star and planet research, his findings have reshaped our approach to understanding the formation of planetary systems and the life cycle of stars. Dr. Stassun is deeply committed to advocating for greater diversity, including neurodiversity, in STEM. He co-founded the Fisk Vanderbilt Masters to PhD Bridge Program, which supports underrepresented students in transitioning to advanced STEM degrees. Additionally, he helped establish the Frist Center for Autism and Innovation at Vanderbilt's School of Engineering, a pioneering initiative designed to assist underrepresented and autistic students in pursuing STEM careers.
I firmly believe that we need to be enabling and nurturing that full human diversity of mind.
Dr. Stassun credits his success to his mother's sacrificial love and belief in the American dream. Just as she taught him, he would encourage others to
Go as far as you can go with it, and who knows, you might even be recognized.
At the heart of groundbreaking advances in mathematics and technology is Dr. Ingrid Daubechies, a pioneering force whose work has revolutionized fields as diverse as digital signal processing, telecommunications, and medical imaging. Her contributions to wavelet theory have fundamentally reshaped how we approach data representation and compression, leaving a lasting impact on industries across the globe. Dr. Daubechies' innovations in wavelet theory enabled the creation of JPEG 2000, a digital imaging standard that has become a cornerstone of modern technology. Her research has enhanced everything from image compression to remote sensing, streamlining industries, and enabling them to operate with greater efficiency and precision than ever before. As the first female president of the International Mathematical Union, she has broken barriers for women and underrepresented groups in mathematics. She has brought mathematical insight into the world of art, using her expertise to solve complex conservation challenges. Her work on restoring masterpieces, such as the Ghent altarpiece and the St. John altarpiece, demonstrates the power of math to preserve history and culture. Through her work, leadership, and dedication, Dr. Daubechies continues to blaze a trail for future generations of scientists, mathematicians, and leaders, proving that no dream is too big and no obstacle is too great to overcome. At the intersection of neuroscience, anesthesia, and innovation lies groundbreaking work that has reshaped our understanding of the brain. Dr. Emery N. Brown has not only deepened our knowledge of brain dynamics, but has revolutionized the field of anesthesia. His research has fundamentally changed how we think about anesthesia and its impact on the brain, offering new insights that lead to better outcomes in surgical procedures.
I began to realize that the approaches and techniques that they were using that could be used to study anesthesia, neurology, neurosurgery, psychiatry, sleep medicine, they're all part of what I'd call the clinical neuroscience disciplines.
A highlight of Dr. Brown's work is the development of sophisticated algorithms that predict how patients will respond to anesthesia, enabling tailored anesthesia treatment plans.
The EEG signal under anesthesia is very clean, so you get a very clean readout of the brain state. And you can use that to understand what the patient state of unconsciousness the patient is in and how you should change your drug as needed.
Dr. Brown's exploration of the brain's complex workings, including how it processes information, alters under anesthesia, and safely returns to consciousness after surgery, raises new questions that continues to push the boundaries of what we know. As the Warren M. Zapol Professor of Anesthesia at Harvard Medical School and Massachusetts General Hospital, and the Edward Hood Taplin Professor of Medical Engineering and Computational Neuroscience at MIT, Dr. Brown is reshaping the future of both neuroscience and anesthesiology and opening new avenues for exploration.
From a young age, Dr. Wendy L. Freedman was captivated by the stars. a fascination instilled by her father's deep love for science and astronomy. This early encouragement ignited a passion that would shape her career as one of the world's leading observational cosmologists. Her journey began with a Bachelor of Science in Astronomy and a doctorate in astronomy and astrophysics from the University of Toronto, leading her to groundbreaking work.
Briefly, what I do is I measure the size and the age of the universe.
She played a central role in the Hubble Key project, refining the measurements of the Hubble constant, a key factor in determining the rate of the universe's expansion. She was also the founding chair of the Giant Magellan Telescope project, a groundbreaking international effort to build one of the most powerful telescopes in the world. The telescope is poised to answer some of humanity's most profound questions, including the discovery of planets like Earth and perhaps life on other planets.
One of the things that I think will be most exciting with the telescope is the possibility of actually discovering life elsewhere in the universe. In the last couple of decades, we've been able to discover planets that are more massive than the Earth.
Her passion for discovery and dedication to scientific advancement continues to inspire the next generation of scientists to explore the universe's deepest mysteries.
A leader in aeronautics and mechanical engineering, Dr. John Dabiri has transformed how we understand and apply the principles of fluid dynamics. His groundbreaking research explores the interplay between biological systems and engineering, revealing insights that drive innovations in renewable energy. He pursued a Bachelor of Science in Mechanical and Aerospace Engineering at Princeton University, followed by a Master of Science and PhD in Bioengineering at Caltech.
Here at Caltech was when I first learned about the idea of studying biological systems and analyzing them in the same way that we analyze a rocket or a jet engine.
Dr. Dabiri's research has significantly advanced the understanding of vortex dynamics and bio-inspired design. His work on fish schooling has informed more efficient wind energy technologies, while his studies of jellyfish propulsion have reshaped ideas about locomotion and even influenced innovations in diagnosing heart disease. Among his many accolades is the prestigious MacArthur Fellowship, often referred to as the Genius Grant. However, Dr. Dabiri considers his greatest achievements to be his mentorship of students. He encourages his mentees to champion unconventional ideas.
Start down that path of exploring the idea. Even if it doesn't work out, I think you'll learn a lot in the process.
Through his research and mentorship, he continues to inspire future innovators to challenge boundaries and uncover the hidden principles that shape our world.
Dr. Angela Belcher is transforming the world by blending biology and engineering to solve some of the world's toughest challenges, from teaching proteins to build batteries to using viruses as blueprints for medical devices. Her work is pioneering innovative solutions that power industries and improve lives. Driven by a childhood fascination for invention and a curiosity for how nature makes materials, like the abalone shell, Dr. Belcher says,
"To me, that is just incredibly fascinating that there's organisms in the ocean that have a DNA sequence that, in this case, codes for a protein sequence, a sequence of amino acids, whose job it is to grow this incredible structure."
This passion led her to biochemistry, where she was captivated by how proteins interact and create life's most intricate structures.
I really fell in love in reality with proteins and the beauty of their structure, and the beauty of how proteins interact with other proteins and how they interact with other molecules.
Her groundbreaking research explores how nature creates materials with extraordinary properties, using genetics to develop new solutions. Dr. Belcher's work is not only advancing materials science, but also revolutionizing areas like environmental remediation and early detection in ovarian cancer diagnostics.
So we're using some of the technology we originally developed for solar cells and batteries for early detection of ovarian cancer, with the hope, and through a big collaboration of amazing engineers and scientists and and clinicians to be able to understand the disease early.
Her mission is clear: to use her groundbreaking research to build healthier engineer solutions for women's health and to build a healthier, more sustainable world.
Known for reshaping how we understand democracy and its impact on society, Larry Bartels is a transformative figure in political science. With a passion for addressing economic disparity through the lens of political reform, Dr. Bartels has dedicated his career to uncovering the forces that drive political behavior and policy outcomes. Dr. Bartels earned his BA and MA in political science from Yale University and a PhD from the University of California, Berkeley. He served as the founding director of Princeton University's Center for the Study of Democratic Politics and is currently University Distinguished Professor of Political Science and Law and May Worthen Shane Chair of Public Policy and Social Science at Vanderbilt University. His work focuses on the psychology of voting behavior, the consequences of political decisions on everyday people, and the intricate connections between economic inequality and governance.
I think the more pressing issue is to try to maintain perspective on how much we know and maybe more importantly on how much we don't know.
For Dr. Bartels, democracy is both an inspiring ideal and a complex puzzle.
Democracy is much harder than people often realize to make work.
Through his work, he continues to challenge political norms and inspire meaningful conversations about how democracy can better serve all citizens.
A luminary in reproductive science, Dr. Teresa Woodruff has reshaped the landscape of fertility and reproductive care. Her research in ovarian biology, fertility preservation, and the health of young cancer survivors has made her a leading figure in improving women's reproductive health worldwide. Her academic journey took a pivotal turn when a college professor encouraged her to ask deeper questions, setting her on a path of discovery and innovation. Woodruff's focus shifted to biology during her undergraduate years, leading her to earn a Bachelor of Science in Zoology from Olivet Nazarene University in 1985, followed by a PhD in biochemistry from Northwestern University in 1989. Today, Dr. Woodruff is a professor at Michigan State University.
At that time, I asked, well, what do we do for young women? And the answer was, well, we should really have them focus on their survivorship. And I knew from my own research that women had all the follicles that contain a single egg that they'll have throughout their lifetime.
In 2006, she coined the term oncofertility, merging oncology and fertility to help young cancer survivors protect their fertility.
And so the long-term goal really for oncofertility is to be a field of medicine that met a need, but that eventually our war on cancer will eliminate the need for oncofertility.
With pioneering research that has advanced ovarian biology, she has become a leading voice in improving women's reproductive health worldwide.
Dr. R. Lawrence Edwards is a visionary geochemist whose groundbreaking work has transformed our understanding of Earth's climate history. By revolutionizing uranium-thorium dating, he unlocked secrets in geological layers, bridging the past and present to reveal how climate events have shaped the world over the last million years. Growing up, Dr. Edwards drew inspiration from his parents' legacy and summers on a remote Isle Royale National Park island, sparking his love for the Earth and his unyielding can-do spirit. His innovative research has improved geological dating precision and unveiled the timing, scale, and impact of climate events. These discoveries provide insight in addressing today's climate challenges.
And then one thing led to the next, to the next, and to the next, and all of a sudden we're putting together these incredible climate records.
His life's work not only sheds light on Earth's climatic past, but also equips humanity with the perspective to navigate its uncertain future. Dr. Edwards inspires future generations to explore, question, and act, reminding us that the keys to solving tomorrow's challenges may lie in the wisdom of yesterday.
Dr. Cynthia Dwork is a visionary computer scientist who has redefined how technology protects privacy, ensures fairness, and builds trust in the digital age. Her pioneering innovations, from non-malleable cryptography and proofs of work to differential privacy and algorithmic fairness, have not only transformed the foundations of computer science, but also shaped a future where technology serves and empowers humanity. Dwork quickly became a leader in her field, making significant contributions to distributed computing and cryptography, addressing key challenges in system reliability and fault tolerance.
I needed to use some cryptography, but the cryptography that existed at the time that I realized I needed it didn't have the properties that we needed for our protocols to work.
In 2006, Dwork, alongside her collaborators Frank McSherry, Kobe Nissim, and Adam Smith, worked together to develop differential privacy, a revolutionary tool that allows organizations to analyze data while safeguarding individual privacy. Her work ensures that sensitive information remains protected, even in a world where data drives everything from medical research to social policies.
I saw a possibility there that cryptographers had learned how to talk about partial information, and I thought that might be useful.
Founding a new technical field, Dr. Dwork has led the charge in developing methods to ensure fairness in AI, making sure algorithms don't unintentionally amplify bias, a critical issue in today's technology-driven society.
What does it mean for algorithms not to compound historical biases? How do we address that?
Now a professor at Harvard, Dr. Cynthia Dwork mentors the next generation of innovators while continuing her groundbreaking research. Her achievements are a powerful reminder that when technology is built with care and purpose, it safeguards our fundamental right to privacy, preserving the dignity of the digital world.
A trailblazer in geology, Richard Alley has reshaped our understanding of Earth's climate history. Alley's career took a turn in 1977 when he landed his first job while in college, working with glaciologist Ian Willens.
And I'm still working on the problems that Ian Willens set for me back then in 1977.
Over decades of research in places like Antarctica and Greenland, Alley has made outstanding contributions to understanding ice.
There's an assortment now of long, really good cores that have been collected in Greenland and Antarctica and in some of the higher of the mountain glaciers that give us this unprecedented view of how the climate system works over fairly long times.
He synthesized evidence that abrupt climate changes occurred in the past, driving hypotheses about their causes and the role of ice in ocean circulation.
My job description has been to go some of the most beautiful places on the planet with some of the best people, learn what nobody knows, and bring it back and try to make it useful.
Alley has shown that even the coldest ice can spark a fire in humanity.
How can you see that and not be excited?
Reminding us that the choices we make today can shape the planet we leave behind.
From its visionary founding in 2010, Moderna has redefined the future of medicine, transforming revolutionary ideas into life-saving breakthroughs. By unlocking the potential of mRNA technology, Moderna has revolutionized healthcare and proven how swiftly science can rise to meet humanity's greatest challenges, condensing years of research into mere months.
We were able to look at both the mRNA platform technology that we had been developing over the decade and the discrete work that we had done on related coronaviruses to take decisions on how to design a vaccine. And that allowed us to move quickly from concept and from having that digital sequence information available into preclinical, clinical testing, and ultimately to get the vaccine into people.
In December 2020, the Moderna COVID-19 vaccine received emergency use authorization, offering hope to billions and saving countless lives. Moderna's mission spans across scientific innovation. It's about accessibility, equity, and impact. By forming partnerships with governments, nonprofits, and healthcare providers, Moderna has worked tirelessly to close healthcare gaps and foster a more connected and equitable world. Today, Moderna's pipeline is brimming with possibilities. From personalized cancer treatments tailored to individual patients to vaccines targeting respiratory diseases, the company's work continues to push the boundaries of medicine. The company stands as a testament to the transformative power of science and innovation, proving that compassion and ingenuity can solve humanity's greatest challenges. Moderna isn't just making breakthroughs, it's building the foundation for a healthier, more resilient tomorrow.
A groundbreaking innovator in science and medicine, Feng Zhang is transforming our understanding of biology and driving revolutionary advances in healthcare. Born in 1981 in Shijiazhuang, China, Zhang moved to the United States at age 11, carrying an insatiable curiosity and a determination to leave a lasting impact.
When I was in middle school in Iowa, my school had a Saturday enrichment class on molecular biology. They showed us the movie Jurassic Park, and we also did some experiments in that class, like working with the bacteria or extracting DNA from strawberries. That just made biology seem so much more interactive, so much more sort of tinkerable. That's when I began to become interested.
This spark set Zhang on a path to tackle some of humanity's toughest challenges. Zhang's path led him to Harvard, where he studied chemistry and physics, earning his bachelor's degree in 2004. He then pursued his PhD in chemistry and bioengineering at Stanford University, which he completed in 2009.
We're motivated by trying to solve problems and making people's lives better, healthier, and making the world a better place.
Zhang is best known for his work adapting the CRISPR-Cas9, a revolutionary gene editing tool. His relentless pursuit of innovation has opened new frontiers in studying neurological conditions and redefined possibilities across biology, mental health, and medicine. Now leading a world-class research lab at MIT, Zhang collaborates with a passionate team.
Many of the things that we have done, I couldn't possibly do it by myself. It's really my team, but also collaborators, and also mentors and a large community of people working together.
A trailblazer in science and innovation, Dr. David R. Walt is renowned for developing groundbreaking technologies that detect nucleic acids, proteins, and small molecules. His fascination with the natural world began in childhood, driven by a sense of wonder and curiosity.
Caught insects and frogs and looked at things in detail. And I think that's what really sparked my interest in science, was just that connection to nature.
This early passion led him to earn a Bachelor of Science in Chemistry from the University of Michigan and a PhD in Chemical Biology from the State University of New York at Stony Brook, launching a career defined by groundbreaking discoveries. Dr. Walt's innovations have transformed medicine, agriculture, and environmental science. Notably, his technology was instrumental in the founding of Illumina, a company that enabled the cost of genetic analysis to be reduced by over 1 million-fold. Additionally, his advancements have allowed the detection of proteins at over 1,000 times lower concentrations than previous methods, enabling the identification of proteins responsible for neurodegenerative diseases and cancer in the blood. As a professor at Harvard Medical School, his work continues to inspire future generations to push boundaries, find solutions, and make the world a better place for all.
Born in 1964 in Washington, D.C. and raised in Hilo, Hawaii, Jennifer Doudna's early curiosity and love for discovery shaped her path to becoming a pioneer in the life sciences. After studying biochemistry at Pomona College and earning her PhD in biological chemistry from Harvard, she embarked on groundbreaking research that redefined genetic science. In 2012, Dr. Doudna and Emmanuelle Charpentier introduced the CRISPR-Cas9 gene editing tool, enabling precise DNA modifications. This revolutionary breakthrough has transformed medicine, agriculture, and biology, earning them the 2020 Nobel Prize in Chemistry and sparking global discussions on the ethics of genetic editing. Now a professor at UC Berkeley, Dr. Doudna continues advancing CRISPR applications to treat genetic diseases and address climate challenges. A champion for responsible innovation, she advocates for ethical guidelines, ensuring these technologies benefit humanity. Dr. Jennifer Doudna's legacy exemplifies how visionary science can reshape the future of life.
He's the father of the mobile phone, a relentless innovator who redefined how the world connects. With a vision rooted in making lives better, he transformed what was once science fiction into a handheld reality. Born in 1928 in Chicago, Martin Cooper's fascination with technology began early.
I watched some boys burning paper with a magnifying glass. You ever done that? You put a magnifying glass, you let the sun come through, and you could burn a piece of paper, and I was enchanted by that. How could people do that?
That curiosity ignited a lifelong passion for engineering, leading him to earn his degree at the Illinois Institute of Technology in 1954, serve in the Navy, and ultimately join Motorola. In the 1970s, phones were bulky devices tethered to cars, but Cooper dreamed of a more mobile device.
We believe that people should be able to talk wherever they are at any time.
Leading a team at Motorola, he turned that vision into reality, creating the world's first handheld mobile phone. On April 3, 1973, standing on a New York City street, he made history by placing a call on a 2-pound device with just 20 minutes of battery life. That single call sparked a revolution, paving the way for the modern mobile world. Now, at 96, Martin Cooper remains a symbol of innovation and inspiration. His pioneering work not only reshaped communication, but also serves as a testament to the power of technology to improve lives.
Renowned for his groundbreaking contributions to medicine and engineering, Dr. Paul Yock, Martha Meyer Weiland Professor of Medicine and Mechanical Engineering, has reshaped cardiology and bioengineering. As founding co-chair of Stanford's Department of Bioengineering and founding director of Stanford Biodesign, he bridges disciplines to improve patient care and train future innovators. Dr. Yock's journey reflects a relentless pursuit of excellence. He earned an A.B. in chemistry from Amherst College, an M.A. in philosophy and physiology from Trinity College, Oxford, and an M.D. from Harvard Medical School. His fascination with the heart's mechanics, valves, flows, and pumps drew him to cardiology.
I really loved the machine part of how the heart worked.
Early in his career, Dr. Yock tackled challenges in angioplasty technology.
Well, I think the biggest challenge for any health technology is that it's a complicated system, and there are a number of hurdles you have to get over. So you have to prove that the technology works and it's safe.
His perseverance paid off. He invented the rapid exchange angioplasty catheter, simplifying procedures and improving safety. He also invented and conducted the initial studies of the mechanical intravascular ultrasound system. Beyond his clinical contributions, Dr. Yock has authored numerous publications, textbook chapters, and over 45 U.S. patents. Through the Stanford Biodesign program, he's inspiring a new generation of medical technology innovators, transforming cardiology and medical technology forever.
Dr. Kristina M. Johnson is an internationally recognized innovator, entrepreneur, and leader whose groundbreaking work spans academia, industry, and government. Her interest in engineering, science, and education was inspired by her parents, Her father was an accomplished engineer, and her mother passionate about the power of education. A pioneer in optoelectronics, Dr. Johnson earned her Bachelor of Science, Master of Science, and PhD from Stanford University, setting the foundation for a career that has transformed lives, created new industries, and educated a workforce for the 21st century.
What my research group and I did was pioneer a new class of optoelectronic materials and devices called liquid crystal on silicon, or LCOS. These LCOS arrays were used in rear projection televisions that were manufactured all over the world. And in fact, we also used them to build optical correlators or pattern recognition systems where we could find spiculated masses in mammograms. We could identify cancerous cells in pap smears. And we could do that at such high precision that it allowed for all the false positives to be screened out so that we give better diagnostics.
Her innovative work with liquid crystal on silicon also has important applications today in high-definition projection displays, advanced 5G and 6G telecommunications, and quantum computing. But Dr. Johnson's work doesn't stop there. In collaboration with her students, she also invented a new class of optical components that separate colors precisely. This technology enabled modern 3D cinema and has been used in hundreds of 3D movies, displayed in over 25,000 theaters around the world, and viewed by hundreds of millions of people. As an academic leader, Dr. Johnson built innovation ecosystems between industry and academia, including the Optoelectronics Center at the University of Colorado and Colorado State University, the Fitzpatrick Center at Duke University, Advanced Semiconductor Fabrication Laboratories at the State University of New York, and Carmenton at Ohio State University. And as Undersecretary of the U.S. Department of Energy, she helped create the regional innovation clusters in the Obama administration. Through her visionary leadership and mentorship, Dr. Kristina M. Johnson continues to inspire the next generation of innovators, leaving a lasting legacy in science, technology, and beyond.
A transformative leader in communication technology, Dr. Victor Lawrence has revolutionized how the world connects. Inspired by President Kennedy's moonshot speech, a young Victor gazed at the sky.
You wonder, how can man be able to get to this moon? And I started looking into it much more, and I found that Senator John Glenn had circled the Earth twice before. So this stimulated my interest in science and engineering.
From pioneering the shift from analog to digital networks to creating biasless rounding arithmetic, Dr. Lawrence laid the foundation for digital signal processing.
So I was one of the first to look at digital filtering and then also start building it.
Dr. Lawrence's work on digital modems contributed to the early access of the Internet, leading to the widespread adoption of the Internet and mobile technologies that we enjoy today. Beyond technology, Dr. Lawrence's work on submarine cables brought reliable connectivity to every coastal nation in Africa. He also led the Bell Labs team that developed the first high-definition TV and digital video technologies and the first secure voice terminals. He attributes his success to teamwork.
You have to stand on somebody's shoulder to see far. But you see, I also hope as in the future, my shoulders are strong enough for the next generation to be able to stand on and see far.
Dr. Victor Lawrence's groundbreaking contributions continue to inspire.
Capturing the world through transformative innovation, Dr. Eric Fossum, while miniaturizing spacecraft cameras for NASA JPL, invented the CMOS image sensor, commonly known as the camera on a chip. His revolutionary technology powers billions of devices, from smartphones to life-saving pill cameras, redefining how we see and interact with the world. Dr. Fossum is the Krehbiel Professor for Emerging Technologies at Dartmouth's Thayer School of Engineering and serves as Dartmouth's Vice Provost for Entrepreneurship and Technology Transfer, bridging the gap between innovation and real-world application. His journey began with a spark of inspiration as a child.
I think I got really interested in science and invention from reading the Tom Swift Jr. book series. It's kind of like the Hardy Boys, but Tom Swift was this inventor and kept having all these adventures with new crazy inventions that he made. That was pretty inspiring to me as a young kid.
Dr. Fossum's path led him to earn a Bachelor of Science in Physics and Engineering from Trinity College and a PhD in Engineering and Applied Science from Yale University. His pioneering work has defined a storied career, yet he credits much of his success to collaboration.
Look, there's always a leader of the team, which was me, technical leader for the most part, but everybody makes contributions and important contributions and have important ideas. And it's important to have that diversity of opinion about what to do and what to try. So I'm always grateful to them.
Despite earning accolades at the highest levels, Dr. Fossum remains focused on the future, driven by his belief that technology is an endless frontier where solving one problem sparks infinite new possibilities.
Transforming the way we fight cancer and deliver life-saving treatments, Dr. Paula T. Hammond is a trailblazer in nanotechnology and medicine, an institute professor and vice provost for faculty at MIT. She also made history as the first woman and person of color to lead the chemical engineering department. She has turned her early fascination with nature and encouragement from a favorite science teacher into work that hails her as a visionary who has redefined how we fight cancer. Her work with nanoparticles is more than groundbreaking. It's life-changing. One of her greatest achievements is her ability to revolutionize how medicines are delivered, bringing tangible healing to patients. This is particularly significant for cancers like ovarian cancer, where traditional immunotherapies often prove ineffective. The nanoparticle technology offers a new approach, potentially overcoming the challenges of a weakened immune response and offering new avenues for treatment.
But some of the surprising things that we've learned along the way is that the way in which we can get that drug to a cancer cell can also enable us to tag on additional components that might help us with getting the immune system to respond to the cancer. If you can get that to happen, that means not only are you killing cancer cells right now, but if new cancer cells show up, like a recurrent tumor, you have the body able to respond to that by a natural immune response.
Despite her scientific brilliance, it is her passion and commitment to her students that is most inspiring.
I think one of the most important things that I do in my work is create an environment for young scientists to develop their skills and feel enabled. And this is something I'm extremely proud of.
With over 320 published papers, more than 20 patent applications, a past role at Moderna, current roles at Elector, Sale Biosciences, and the MIT Engine, Dr. Hammond's work continues to redefine what's possible in science and medicine.
For 175 years, Pfizer has been at the forefront of healthcare innovation, delivering life-saving treatments and vaccines that have transformed lives around the world. During the global COVID-19 pandemic, Pfizer's groundbreaking partnership with BioNTech led to the rapid development of one of the first mRNA-based vaccines, earning regulatory approval in record time. This achievement saved millions of lives, demonstrating the extraordinary power of science to respond swiftly to global crises. But the impact of the vaccine extends far beyond the pandemic. It has redefined the possibilities of mRNA technology, unlocking new frontiers for treating infectious diseases, cancers, and genetic disorders. Pfizer's unwavering commitment to accessibility ensured that the vaccine reached communities across the globe, overcoming barriers and helping reduce health disparities. From responding to urgent public health challenges to pioneering cutting-edge scientific breakthroughs, Pfizer's innovations are shaping a healthier, more equitable future. This enduring legacy underscores the transformative power of science to turn humanity's greatest challenges into sources of hope and progress.